Hi, I will start today by explaining chapter 8 in mechanics, M1, which is moment. And I will be discussing in this video the first section, which is how to define moments of a force. Imagine you're holding a ruler. You will be holding a ruler by simply putting, let's say, one of your finger on one edge of this ruler, let's say point O. And with your other finger, you want to, again, with your other finger, you want to push this ruler upward. Okay, so it's as if you have a force in here just to push this ruler upward. So imagine how this ruler will react. It will start to turn. Okay, so this ruler will start to turn about O. In which direction? In this direction, which is an anti-clockwise direction. So the moment of a force around about O, which I can denote it moment about O. So always I need to specify the moment about a fixed point, which I call it in mechanics a pivot. So O in this case is my pivot, and I can find the moment about O, which will be defined by the force, this force, multiplied by how far this force is from the pivot or from the fixed point. So if we multiply F by D, it gives us a measure of the amount of turning force that we can supply relatively to O. So the moment in general, the moment, how can I define a moment, is the turning force. But always I need to find the moment or study it about what? About a pivot or about a fixed point. What I care other than the magnitude of this force and how far is it from the fixed point or from the pivot, I need to define its sense. And its sense will be whether this turning force will be clockwise or anti-clockwise with respect to O. In this case, it will be clockwise. It will be anti-clockwise because, again, if you put one finger about on O and the other finger to just push this force upward, you will find that this force with respect to the pivot will be going in an anti-clockwise sense. The unit of the moment will be the unit of the force, which is a Newton, multiplied by the unit which is of the distance, which is meter, which is in this case a Newton meter. If I take this same example, which is the ruler in this case, and then again you fixed or you put one of your finger at one edge of this ruler, which is at point O, and let's say with the other finger you try to push this ruler down. So you want to try to push this ruler down. So can you imagine how this ruler is going to turn around O? So again around O, which means this force will be pushed, but as if you are pushing it towards O. So you will find that it will be turning in which direction? In a clockwise direction. So if I want to find in this case the moment about O, which I can denote it as M with respect to O between a bracket, let's say the force in this case it's a 20 Newton, and let's say the distance of this ruler is 30 centimeter or 0.3 meter, then the moment about O will be 20 multiplied by 0.3, which is 6 Newton meter in a clockwise direction. So I always need to specify whether it's a clockwise or anti-clockwise. And later on we have to specify before we start what do we want the moment in which direction to be positive. So I specify a moment around O, and I put this arrow to specify that my positive direction that I wanted, in this case it's a clockwise direction. You will ask me, what if I specify my moment around O to be positive in the anti-clockwise direction? It will be very simple. The only difference that you will be writing is minus 6 Newton meter, because you chose your direction to be anti-clockwise, but in fact you're pushing downward in this direction towards O, which is in a clockwise direction. So I just represent it by a negative. Let's say I want to find the moment about O. So let's say in the following question I want to find the moment. I want to find the moment about O. Let's say I have a force in here which is 8 Newton, and the distance is 3 meter. Then the moment about O, let me take the positive sense to be again anti-clockwise. Now it will be 8 multiplied by 3. Now put your finger on O and try as if you're pushing through the arrow, but with respect always towards the O, our fixed point. I will see that it will be turning anti-clockwise. So that's why I keep my answer positive. So it's 24 Newton meter anti-clockwise. If I take another example, if I have, this is the force, and I have point O in here. Let's say O is away like 5 meter and the force is 10 Newton. Again, the moment about O, again this is the force, it will go in this way, which means it will go clockwise. So if I want to take the moment about O anti-clockwise to be positive, then I will be getting it minus 5 times 10, which is minus 50 Newton meter. Why the minus? Because this force is going clockwise, and I decided the moment to be in its positive direction to be anti-clockwise. So this is part B. If I go to part C, I have, this is the force. Let's say this force is 14 Newton, and this is point O. How can I know how far is O from this force? I need to extend the force on a line, and then now it will be O will be away 3 meter, and this is a perpendicular. Now again, put your finger around O, and then if I take this arrow towards O, then the force will be acting anti-clockwise. So it will be 3 times 14 in this case, which is 42 Newton meter in an anti-clockwise direction. This is if I have here point O, and here let's say it's perpendicular, and O it's inclined at 45 degrees. If this is a 5 meter, I need to find the perpendicular distance with respect to this force. Let's say this force is 10 Newton, so I need to resolve for this distance over here, which will be 5 times sine 45. Now what will be the moment around O in this specific example? If I put, again, if you stand at O and then you push this force towards O in the same direction as the arrow, you will see that it will be going clockwise, in a clockwise direction. So if I take anti-clockwise to be my positive direction, my answer in this case will be negative. Negative 10 times 5 sine 45, which will give me minus 25 square root of 2 Newton meter. Again, I'm telling you this is in case I'm taking in this question anti-clockwise to be my positive direction. And in fact, it can be anything. It can be clockwise or anti-clockwise, it doesn't matter. In the moment problem, you choose what is your positive direction. So this is the first section in this chapter, which just tell us the moment. How do we find the moment of a force with respect to a fixed point, which is equal to the force multiplied by the distance, the perpendicular distance, and the unit will be in a Newton meter. And we will be extending this section in the next video to many forces applied with respect to a fixed point, not only one force. Thank you.